This is section 2.1. The title of this section is Input and Output. In this section, students will evaluate a function for a given input using a formula, table, or graph, use algebra to simplify expressions obtained when evaluating a function using a formula, solve an equation of the form f at x equals b for the input using a formula, table, or graph. For some functions given by a formula, you will need to use algebra to solve the equation. For more complicated formulas, you may need to use a graphing calculator or computer to solve the equation. And lastly, you will interpret the statement f at a equals b when the function models a relationship between physical quantities. Let's start this section off by evaluating a function. To evaluate a function, we determine the value of the dependent variable, what we sometimes think of as the y value, given a value of the independent variable, what you sometimes think of as the x value. So let's take a look at an example. The function that we use to convert from degrees Fahrenheit to degrees Celsius is c at f equals 5/9 the quantity f minus 32. So we'd like to first take a look at what would be the value of c evaluated at 32, and then what does that mean? So in order to do this, remember what we do is we substitute in the number that appears inside the parentheses for the variable that we see up above that appears inside the parentheses. So inside the parentheses we have 32, inside the parentheses we have f. So we're going to substitute in 32 for f. So if we do that in our formula, that gives us 5/9 and then 32, that's our substituted value, minus 32, and if we do the math out, we get 0. So what we notice is when I substitute in 32, I get out 0. Well, what does that mean? Well, in order to understand what it means, we need to understand what the function is telling us. So what we learn is that c at f is equal to some quantity. Notice the f in the parentheses is degrees Fahrenheit, and what we're getting out, recall, is degrees Celsius. And so what we know is we have 32 degrees Fahrenheit, and that corresponds to 0 degrees Celsius. And so what does that tell us? That tells us a temperature of 32 degrees Fahrenheit is equivalent to a temperature of 0 degrees Celsius. And you'll notice when I solved the problem, that's exactly what I had. Let's take a look at another example, and this one, let's look at the worked out example. So what we would like to do is compute c at 50 and explain what it means. So c at 50, again, what we do is we substitute in the 50 in for the f. So here's my 50, it goes in for the f. And so here's the f in my formula, so I'll put the 50 in the same location. So I get 5/9 multiplied by the quantity 50 minus 32. And if I do 50 minus 32, that's 18. And if I complete the math and do 5/9 multiplied by 18, I get 10. So again, what does that tell us? Well, let's start off. I know I have c at 50, and the computation gave me 10. Remember, 50 is degrees Fahrenheit per units, 10 is degrees Celsius, so a temperature of 50 degrees Fahrenheit corresponds to 10 degrees Celsius.